Hello and welcome to another video, this time on June 21 paper from Stats A-Level, or the Maths A-Level, the Stats component. This question 4 is on probability, and this looks like quite an interesting one as well. We've got 3 circles overlapping and lots of probabilities to find. It's about a student reading magazines about green issues, one about equality and one about sports. Okay, so cool. Obviously you can read all 3, you can read only one, you can read none of them. And yeah, etc., etc. Find the proportion of students in the college. So the proportion, that's a way of not using the word probability, who read exactly one of these magazines. Well, that's this one, and this one, and this one. 0.45, 0.53. So just 0.08 plus 0.09 plus 0.36 is 0.53. If they ask for proportion, I tend to prefer saying 53%. I just think that's more obviously as a proportion. Okay, no student reads all 3 magazines, and P of G is 0.25. So nobody reads all 3. So little p must be 0, and P of G is 0.25. So 0.25 minus 0.08 minus 0.05 minus 0. Well, that will equal Q, and that gives us a value of Q of 0.12, I think. Cool. Okay, right, well, we're getting there, aren't we? It's nice, actually, if you've got this in the exam, to actually write these values down on there for later, isn't it? So that we know. Okay, right. Now, this is very similar to the last question I did in 2020. Okay, I'm now going to find the value of R and T, because I've got the probability of S given E is 5/12. Well, straight away I'm going to go to the formula here, and I know that's the probability of S and E over the probability of E. Yeah, what you're given. And that, of course, means that 5/12 is the same as, well, what's S and E here? It's P plus R, but as P is 0, it's simply R. We're going to divide it by what we're given E. Well, that's 0.05 plus 0.09, which is 0.14, plus R. And then it's just a case of, can you rearrange this equation? So I'm going to cross multiply here. 5 times 0.14 plus R equals 12R. So 5 times 0.14 is 0.7 plus 5R is 12. Oh, missed an R there. 12R. And so that's going to give me 0.7 is 7R. So it looks like R is 0.1. When the number works out quite nicely, probably done it right, haven't you? Okay, we've now got to find the value of T. Once again, just take all of these away from 1, and T is going to be equal to 1 minus, I'm annoyed I've got to actually even write it down, but I like getting all the method marks. You never know when they're going to be stingy. Okay, so I'm now going to just subtract that from there, and I'm going to get 0.2, I think, for that. Let's see, 0.13, 0.25, 0.34, 0.44 plus 0.36, 0.8, yes, so 0.2. And then the last bit, what have we got to do here? Well, this is a classic question where they're asking you to test for independence, yeah? Determine whether or not S and not E and G are independent. Now, I've made it slightly more complicated by doing that, but not just having one single event, but saying S and not E. Okay, well, let's do this then. So if they're independent, then the probability of S and not E times by the probability of G equals the probability of S and not E and G. Yeah, and statements you don't need a bracket around. You can just link them because it's an extra condition essentially. So you don't need the brackets are unimportant. Basically, it doesn't make any difference. So let's just have a look at this from the diagram. S and not E. What is S and not E? It's going to be these two figures here. They're in the S section and not in the E section. So it's going to be 0.48. The G is going to be all of this, so that's 0.25. And let's just do this in bits. Let's just say left-hand side is going to be equal to 0.12. Yeah. The right-hand side, well, that's S and not E, and it's in G. So it's going to be in S, it mustn't be in E, and it must be in G as well. That's just a 0.12 here. oh look, this holds, therefore they're independent. The left-hand side does in fact equal the right-hand side. Hence, the two events are independent. And that's it. That's what I call a test for independence. Yeah, if P of A times P of B equals P of A and B, that is a test for independence, and if this holds, then they're indy. Yeah, they're independent. So always use that if they ever ask you for a test of independence. Okay, hope that was useful. Keep up the hard work. Bye-bye.